Hey, how's it going, everybody? Want to make a video about another historical shooting method that is actually apparently from the 1938 Torpedo Schießvorschrift, which is the torpedo shooting regulations that obviously were in effect right before the war started. This particular method, I don't believe, was used extensively by U-boats. I think it was used primarily by surface ships, but it's actually an interesting method to do because you don't need any data. It's purely uh, a a dataless shooting method that you've basically achieve a constant bearing to the target and set the TDC in a certain way that reflects the data or I should say the gyro angle from that constant bearing, estimate a rough range, and pull the trigger. So uh, it works along the same principles as the Ausdampfen. In fact, this shooting method is called the Ausdampfverfahren. Ausdampfverfahren is, of course, also used to calculate target speed. I've gone over that in my other videos. Achieving a constant bearing to the target and then applying a formula to derive target speed. Well, this works a little differently. You're basically entering your own speed into the TDC, the bearing to the target as the angle on bow, estimating a rough range, and then firing. So what I've done is I've dived to periscope depth. I'm in the tutorial here. I've got the target off of my um, starboard stern here. You can see, and we're going to actually what we'll do is we will try to achieve a constant bearing to him. We'll try to achieve a constant bearing to him by turning, and then we will. What we'll do is we'll wait until we think he's at a good range, and then we'll go ahead and fire. So we should probably hurry because he's relatively close. So I will start a turn to put him. We'll just start with 90. We're going 3 knots ourselves. All right, at slow ahead. So we know that. But we'll put him on our 90 to start with, and then we'll have to just feel it out to see how we can achieve that constant bearing. And I'm hoping we're not too close already for this, but I should be okay. So, and then for the range, I'll simply just use an estimate of the mast height. Whoa, got some issues here with my system being overloaded a little bit, but we'll get on this course here. Make sure we're not. Nope, we're still good there. Yeah, it's kind of a fun method to do. I made a video years and years ago using Silent Hunter 3 to demonstrate this. It's a pretty decent method if you can get it to work. And when I say get it to work, I mean um, to be able to have the time to achieve that constant bearing and whoops, almost there. Time to achieve that constant bearing and maintain it so that you can fire. Alright, so he's actually still gaining on us at 3 knots. Okay, so we can't actually turn anymore to get a constant bearing on him. We have to increase our speed. So what we'll do is we'll go half ahead and then 10 slower will give us 4 knots. We'll see what that does. So now we just simply watch. Because when he's at 90 like this, you can't. There's no way. Any which way I turn now, I'm gonna lose ground on him even further. So we'll see if getting a little further. Now we might even just try to go half speed ahead, period. So that give us about 5 knots. So then yeah, so that's going to get us hopefully up to about 5 knots. I'll just keep watching. Yeah, so he's still gaining on us ever so slightly there, but as we pick up speed here, we'll see if that changes. Yes, it's starting to change now, almost a little bit there. Still gaining on us ever so slightly. So this is handy if you are absolutely in a pinch and you've got no way to get data. If it's fog or whatever, and the targets are already on top of you, or and you can achieve a constant bearing relatively quickly. This can allow you to, or if you just simply want to try it out and don't even want to bother with getting data, you can certainly use this method to be successful. So yeah, he's gaining on us still ever so slightly there. Ever so slightly. So we'll check our speed again. We're at 4.5 knots there. So the only thing that really remains at this point is to we'll go great speed ahead, and then we'll go 10 slower, 10 slower again. Let's see what that gives us. So 2 times 10 slower there. We'll see what that does for us. It'll be pretty close at this point. So now we're actually gaining on him ever so slightly. And that's at 5.3 knots. So 5.4, I'm going to go both engines 10 slower again. See what that gives me. That should bust us down to maybe just a hair over 5 knots, I would say. And we'll see what that does. Maybe it's going to hover at 5.4. Oops. Yep, still gaining on him. 1.4. Alright, I'm going to go another 10 slower from that. And let's see what that does. Still gaining slightly. And if I can't achieve it with speed changes, I'll have to start turning in. But this is getting pretty close here. Ideally over a couple 2-3 minutes to have a constant bearing. I'm going to change 10 degrees to starboard. So 343. Just try to further suppress that bearing change. Alright, see how that does. Okay. Just watch him a little bit. Watch very, very closely. Very closely. Okay, he may be gaining on us ever so slightly there even. So we're going to go 5 degrees back again. And this should get us pretty close. Okay. That's probably close enough right there. So what I do at this point, two things. Leave the scope exactly where it is, jump off, go down and get my speed exactly. My speed is 4.8 knots. Okay. So I come up and besides setting the rest of the TDC up as you normally would, I set 4.8 knots. I set my own speed roughly there. Now, the bearing, which is 84 degrees, I set that as the AOB, bow going in the direction of the ship. So I set 84, I set the bearing to the angle on bow. So that's 84, which is right there. Okay. Now all I need to do is estimate a range. It's pretty close. So what I'll do is I'll just do I'll just say maybe he's 35 meters tall. Okay, 35 meters at about just a hair over 2 tick marks. 35 hair over 2. Let's call him like 1600 meters away. Okay, so then I'll set 1600 just like that. I mean, I could wait. What I ideally would wait until he's like less than 1,000, but just for sake of keeping the video moving, we'll go from here. So, all right. So I've got the constant bearing set as the angle on bow with bow going left because he's bow left, right? And then I've got my own speed set as target speed. Okay. So we should all be set here. We can shoot really anytime. We can go ahead and fire. Let me just get down and offset here. Oops, what am I doing? Going the other way here. There we go. Ish. Okay, now we'll watch. Okay. Alright. So, this I'm tracking pretty nicely here. We'll see what happens here. Should be good. And the range might have been a little off, let's say using a estimate of range height, or excuse me, estimate of mast height, but range is for a shot like this, range is absolutely going to make a difference because of the fact that because you've got no because of parallax, okay, and you can see in that case it actually did make a difference. We hit forward, but we still hit the target. Okay, so you don't need to have an absolutely spot on range. You can see, I mean, I bet you my range estimate just using a 35 meter estimate was probably in the ballpark of, because when we looked at this, it was about 1,000 meters, a little over 1,000, and we estimated 1,600. I mean, that was off by at least a couple hundred meters. Okay, and at an extreme gyro angle like that, so you can see even at an extreme gyro angle and a relatively narrow impact angle, even a rough range will still get you there. We hit forward, but you can see that's it works. It's just simply trigonometry. It works. Getting that constant bearing allows you to use your own speed set to set as target speed. Read the constant bearing off from the bearing dials, and then set the angle on bow to be that bearing, making sure the bow is pointing in the right direction, and then estimating just a rough range. That's all we needed to do is a rough range, and being able to hit the target. So you can see we you saw before we hit forward there. So yeah, we could even shoot again just to demonstrate now that we're closer. This is the tutorial where range is really going to make a difference. Let's see what it does. So let's say we're going to estimate range again, and we're still going to be off. Let's say we estimate like 900 meters, and it's really 600 meters. Okay, because I think that's what it is. Yeah, 600. So we're going to try this again. We'll just see what happens when it's that far off. So, so we'll go ahead and shoot again here. So let's say we did wait. Let's say we did in fact wait, and we waited for the target to get a little closer. So you can see it's still going to hit forward. Our range estimate was still high, but this time it was like 300 meters high. And so we will see what happens there. We still hit, okay? We still hit. So you are able to be off by a pretty decent amount on range, and still be in the ballpark, even at an extreme gyro angle like that at a close range. You know, there's still wiggle room there. That's my point. Okay, so anyway, so that's the method. That's the Ausdampfverfahren, getting a constant bearing and using that as an actual shooting method to in lieu of getting angle on bow and speed, etc. And again, to recap, all you're doing is you're getting that constant bearing over at least a couple minutes, going down, getting your exact speed, setting your speed to the target speed, setting the constant bearing as the angle on bow, going with the bow, or with the bow going in the correct direction, and then going in and just estimating a rough range, going back to your center of your target and firing. That is pretty much it. So try the method out. Let me know how it works out for you, and we'll talk soon.